think we're ready to rock. Let me turn your attention back here. I thought it's worthwhile to do a little bit of review on some exponential and log properties before we get started. So if you didn't know, exponential logs are just opposites of each other. So like I was talking with Maddie, 2 to the third is 8, correct? That's in base 2. 2 to the third power, 2 times 2 times 2 is 8. So vice versa, that we're using logarithms, I can describe this same relationship. Log base 2 of 8 is 3. What exponent do you have to raise 2 to make 8? 3. Our focus here today and tomorrow is going to be on derivatives of exponential and log functions in multiple bases. Some other properties of exponential and log functions that are helpful to remember. I have on the board, these are some basic exponential properties. When I multiply exponents, x to the a times x to the b, what do I do with those powers? I have ax is multiplying, I have bx is multiplying, so altogether that's a plus b total x is multiplied together. It's the opposite. How do you divide exponents? You would subtract power to a power. What if I have like x squared to the third? I have a power raised to another power. I have x to the a to the b. I would multiply those exponents because I have b groups of x to the a all multiplied together. Now there are corresponding log properties that are based off of these 3 beginning relationships. They're just a little bit backwards because logs are the opposite of exponential. The natural log of a times b, when I'm multiplying these 2 values together in a logarithm, I can expand it as the natural log of a plus the natural log of b. Or I guess I could write this as a log. Let's do that. Log of any type, log of any of these. Log of ab equals log a plus log b. When I multiply logs together, I can expand that using a sum based off of this first property. Did everyone kind of see the connection there? Same thing, just a little bit backwards in log form. Okay. Log of a divided by b. How would I change what I had in the top log? Log a is minus log. When I divide logs, I can expand using a difference. How about power of logs? Log of a to the b. Write it like that. This is similar to the power to a power relationship. I can take this b and multiply it times that initial log. Take that b and multiply it as a constant out front if you want to think of it. When I have power to a power, I multiply these exponents together, a times b. So when I have a log to a power, I can multiply that power times the log root in a similar manner. Kind of that same connection up to here in exponential form gets me this property down here in log form. Those may or may not be helpful, but it's always good to review. All right, so we got some review on logs. Now let's start looking at what the derivative of exponentials and logs are. All right, up on Desmos, once I get the Up on decimals, I have the graph of f of x equals e to the x. Have we not sketched this a bunch of times too when we looked at sketching derivatives back in standard 6?
Yeah.
What should the sketch of the derivative of e to the x look like?
Just trace
It's second method.
Why don't I just trace it?
It's the same thing, right? Wouldn't the derivative just overlay right on top of the original function? It's going to be a positive derivative as the graph is increasing from left to right. The graph is starting very shallow, starting very flat, and as I move from left to right, it's getting steeper and steeper and steeper. The derivative of e to the x is its own function. It's also e to the x. As I kind of click that off and on, you see how it's just the same thing over the top of itself? E to the x is the easiest derivative to remember because it's the same as the original function. The derivative of e to the x is also e to the x. Easy. On your formula sheet, that is going to be, where do I find it here? Number 10. Number 10 is the derivative of exponential in base e. On the board here, the derivative with respect to x of e to the x is e to the x. You just saw in decimals. The graph of the derivative of e to the x just was the same e to the x on the screen. Now, what if you have a function e raised to some other function? If u is a differentiable function of x, the derivative of e to that function u is e to the u times the derivative of that function u prime. So for example, the derivative of e to the 3x would be e to the 3x times the derivative of 3x, which is 3. I have e raised to some function of x, e to the 3x, so I take the derivative of each piece. The derivative of e to the 3x is e to the 3x. Now multiply that times the other function. The derivative of 3x is just 3. So altogether, 3e to the 3. This e to the u is helpful when I have functions of functions. One function is the exponential in base e. The other function is what's in the exponent. This u function, this inner function. All right, we've got the exponential derivative. Derivative of e to the x is e to the x. Let's look at ln of x. Let's look at a log now. Here's a graph of the natural log of x. ln of x is up on the screen. I think we've also graphed this derivative, haven't we? Is the derivative going to be positive or negative? Positive, because the graph is increasing from left to right, correct? But it's going to start very steep, and as I go from left to right, the graph gets flatter and flatter, so the derivative should approach 0. Here's a sketch of what the derivative would look like in purple. Strictly positive, but starting very steep and getting shallower, getting flatter, approaching 0 as I tend to the right, as I go to the right. This is the same as 1 over x. The derivative of natural log of x is 1 over x, so long as 1 over x is greater than 0. I've got that in this bottom row here. The derivative is 1 over x. So, derivative of natural log of x is 1 over x. But what if you have the natural log of some inner function? For example, what if you have the natural log of 3x? There's a function inside the natural log. There's a differentiable function u in terms of x inside the natural log function. So using this rule down here, the derivative of natural log of u is the derivative of natural log u, 1 over u, times the derivative of that inner function u prime. Take the derivative of each piece. Derivative of natural log, 1 over u. Derivative of u, u prime. If I multiply those together, 1 over u times u prime becomes u prime over u. What's the derivative of natural log 3x in that respect? Well, that would be this like your u right here. 1 over u times u prime. What's the derivative of 3x? 3. I take the derivative of each function separately and then multiply them together. The derivative of natural log is this 1 over 3x right here. Derivative of the inner function, derivative of u, derivative of the 3x is the 3. All right, so let's just try a couple to see this in action. Oh, I'm sorry, on your formula sheet, I forgot to mention this. Natural log derivative, number 9. We got number 9 for the natural log, number 10 for exponential and basic. Oh shoot, I actually did number 1, just about. Try number 1. I did pretty much the same thing. I did ln 3x. This is ln 2x. Use this rule right here. What's the u in this sense? What's the inner function? What's inside the natural log? Which other function? 2x. Think of this kind of like your u in that sense, if it helps to use the formula on your formula sheet. There's a function within a function, so I have to take the derivative of each piece respectively. Take the derivative of the natural log portion, take the derivative of the 2x portion, and multiply them together. All right, so if I use this formula here, 1 over u would be 1 over 2x. But then do what? By 2, because that is the derivative of the other function, the 2x, right? 1 over u is the derivative of the natural log portion. I also need the derivative of the 2x portion for this equation. So times 2. That's 2 over 2x, which is then just 1 over 2x times 2. That's 2 over 2x, which what cancels out. Derivative of ln 2x is just 1 over x. Try number 2. ln x squared plus 1. What's that given derivative? What's the inner function in this sense for this particular equation?
X squared.
So I multiply each derivative for my final answer. Take the derivative of ln, take the derivative of x squared plus 1, put them all together as a product. All right, so 1 over u times u prime, that's 1 over x squared plus 1 times the extra. What's the derivative of x squared plus 1? That's putting this all together, 2x over x squared plus. Number 3, g of x equals natural log of 1 over radical x minus 3. So I'm going to do 1 over 1 divided by radical x minus 3 times the derivative of 1 over radical x. That's going to be a negative. I don't want to do that. Let's see if we can use some of these log properties from the backboard to rewrite this log function and get a better way to take the derivative. So I have a quotient here, 1 over radical x minus 3. How could I break this apart into a couple of different logarithms?
ln 1 minus ln of x minus 3 fractions.
Okay, so I'm going to try and do that. That at least gets rid of the quotient in there. That looks a little bit better if I'm thinking about how I want to take the derivative. Let's maybe work with, I don't like derivatives of radicals very much. If there's a way to get rid of this radical somehow, I might be able to get a better way to take the derivative. X3 over 2. What's this as a, I kind of see where you're going there, Kim, but what's the radical as a power? What's the square root as a power?
Square root of the power?
Yeah, if I want to write the square root as a power, as an exponent, what's the square root as a power?
Well, this regular square root is
1/2. So g of x equals the natural log of 1 minus the natural log of x minus 3 to the 1/2. What do I do with the 1/2 now using these log properties on the back wall? The natural log of some base to a power, that power can go out to the front. Much easier derivative now. It's worth our time, trust me, to do a little expanding before I take the derivative. You want to know what the natural log of 1 actually is? Not quite. No. The natural log tells us what power e has to be raised to make 1. E to what power is 1? Anything to what power is 1?
0.
0. So the natural log should just be
0.
0. Isn't this basically just nothing? Natural log of 1 is 0 because e to the 0th is 1. Let's take the derivative of negative 1/2 ln x minus 3. I'm actually ready to take the derivative. Negative 1/2 times the derivative of ln x minus 3. That would be 1 over x minus 3 times 1, because the derivative of x minus 3 is 1. G prime of x is either negative 1 over 2 quantity x minus 3 or negative 1 over 2x minus 6. How do you want to write that as? We did some logs, now let's try some exponentials. These last two are e in base e. What's the derivative of e to the x? It's going to be the easiest one I ever ask you to remember. The derivative of e to the x should be e to the x. But now I have e to some function. Rather than e to the x, it's e to a function of x. It's e to the 2x minus 1. So we're going to use this formula here. The derivative of e to some function of x. U is some function of x. The derivative of e to some function of x is e to the u times u prime. I take the derivative of each piece and then multiply them all together. The derivative of the exponential portion is just e to the u. The derivative of the u function in the exponent is u prime. So now multiply them all together. These are pretty slim because they're easy derivatives. E to the 2x minus 1 times where's the extra 2 coming from? Derivative of 2. Derivative of 2x minus 1 is 2. So that needs to go in our final answer. Number 5 here. One last one to try, and then we'll get some practice here for you. F of x equals e to the negative 3 over x. So the derivative f prime of x is the same function, e to the negative 3 over x. Now, how do I get the derivative of negative 3 over x? How could I rewrite negative 3 over x to get a better function to take the derivative of? So we use the power rule. If I divide by x to the first, that's the same as x to what power?
Negative 1.
Just use a negative exponent. 1 over x squared is x to the negative second. 1 over x to the third is x to the negative third, and so on. Negative 3 over x is the same thing as negative 3x to the negative first. So that derivative would be negative 3x to the, no, sorry, do that wrong. Positive 3x to the negative second. Get rid of that negative exponent by putting it back down into the denominator. So 3 over x squared. So I put this all together. 3 times e to the negative 3 over x, all divided by x. These are the easy ones. Tomorrow it's in base A. It's going to be a little bit more complicated. Instead of e to the x, it could be like 5 to the x. Instead of natural log, it could be like log base 2 or log base 3. Some other base. Could I have you guys grab your laptops and let's